So I'm Tobias, as said. I'm coming from the hardware, basically. So we don't do applications, we do chips, time-of-flight depth sensing chips. And we're based in Siegen. And I want to show you a little bit of what products we are in and what you can do with our development kits to get on the road to being integrated into products. So why am I here? Obviously to support my not available CEO. So that's my presentation anyways. Basically I want to show you what you can do with time-of-flight cameras that we provide. For example, the Camera Pico Flex, which is one of our development kits. And basically we can do black and white images, which is not that that interesting, but since we do a depth sensing technology, this is a color-coded depth map where you can measure the distance in each and every pixel, 38,000 at this point, but at the end of the day you have a 3D point cloud. And this is the base for everything we will talk about from now on. This is what PMD provides, a 3D point cloud out of these cameras, out of these sensors. What you can do with it is, of course, you can do scanning. You can use a SLAM algorithm to stitch together this 3D point cloud stream, and we took my pretty face here and to show what a scan could look like. So I did it myself, so forgive me if it's not complete because my arms are limited. But we can do much more. Basically, we are integrated with our products already in the Meta 2. This is the product we have also at our booth. What we do also is hand and finger gesture recognition based on skeleton models or based on other approaches, but always based on the point cloud, of course. Inside-out tracking, 6 degrees of freedom. The fine thing about the point cloud is that you know the origin of the point cloud because you have a direction and the distance. So the tracking is quite easily and comes in handy. We're coming from an industrial. Our mother company is IFM Electronics, doing industrial sensors. So of course we do this since 15 years. Face scanning, yes, we can do that. It's not structured light, as Apple tells everyone. You can do this with time-of-flight as well. We can show you at our booth as well. Computational photography. Use the smartphone and the depth sensor in the smartphone to enhance the photography capabilities. You can use it in robotics or in drones to do collision avoidance or whatever you need in terms of orientation or scanning the environment, surveillance. Yes. So to give you a little overview, and it's again my face, our marketing is misusing me a little bit, to give you a context in this 1-minute video. We have different camera systems that we give out to developers to work with the 3D data. We can work outdoors because we have a special pixel design, and we plug this development kits also on a drone using the robot operating system, so we are ROS compatible, and played around with that a little bit. So a huge variety of use cases we can accomplish. Time-of-flight is highly scalable by just scale the amount of light you spend to illuminate the scene. It's an active technology. We can do long range, short range at the same time. Scanning, as said,
3D scanning.
Scan to print is shown here. Looks a little bit bulky, but this is just the intermediate result.
Running on major platforms.
And this is the small one, Tango-like, and we have an intermediate and a surveillance-like camera system to give a starting point for developers to start closest to their target application. Okay, and of course we are in the Google Tango phones. So that's our technology, which is in the Zenfone AR and the Lenovo Fab 2 Pro. Tango is more than the pure time of flight. Time of flight gives the depth sensing part, or provides the depth sensing part, but there's also the standard RGB camera, there's a fisheye for feature tracking, and of course all the accelerometers and the position sensors that give a whole bunch of data sets that Tango is evaluating to do a very good and robust tracking. And the Google specs are like up to 4 meters, 1% of the distance error accepted, and the depth information is coming at 5 FPS, a low power consumption, 38K pixel, and so on. And by the way, Tango is not that. AR kit is there. I'm used to that. AR Core is the reaction of Google, of course, and a Tango-like rebranded thing will be there again. As a matter of fact, OEMs will try to differentiate against the others, so they want to have the better 3D scanning. And for the very good 3D scanning, you need 3D data. Fact. Tango use cases, just very shortly, augmented reality gaming, then measurement utilities. The main idea was indoor navigation, of course, coming from Tango. And if you want to do indoor navigation and you scan your environment, then of course you can do the 3D models out of these scans by the SLAM algorithms provided by the Google guys. We are also going into the automotive space mainly for in-cabin monitoring or driver monitoring, drowsiness detection, all that kind of stuff, entertainment, gesture input, finger tracking again, hand tracking again, and we benefit from a very robust pixel design against ambient light conditions. And if this works, I can start the video, hopefully. I have no idea how to navigate. Can you click on the bottom right video? Thank you. The left-hand side is our grayscale image, which is clearly independent from the ambient light you have in the car. And this is because we can distinguish between the amount of active light we spend to do the measurement and the ambient light. And this is really beneficial for algorithms that work on that kind of data, that you have a constant illumination in this environment. We spent lots of efforts to do that pixels. But coming back to the beginning. So this is the CAMBOT PicoFlex we give out to developers. This is a time-of-flight-based depth sensing camera with an Infineon chip in there. We are in collaboration with Infineon. ToF means time of flight, so we're measuring the travel time of the light. pmd is the working principle, so it's called photonic mixer device. So the pixel. pmd is also the company name. And pmd and Infineon have a long-term relationship, so let's say we are best friends. Infineon sells the chips, we do the system layout for time-of-flight-based cameras. Where this is where we have a knowledge on a long history. Very short introduction. I promise to keep it short. Time-of-flight sends out, so we're doing continuous time-of-flight or indirect time-of-flight. It's not sending out a pulse and measuring the real travel time of the light. We are sending out a modulated light. We have the initial signal applied at each and every pixel, and we do a convolution of this optical signal coming back from the reflection of the object with an electrical signal in the pixel. This is photonic mixer device. And the result is a autocorrelation function, that seesaw function, bottom right. And we reconstruct this waveform and detect the phase shift phi. We know the amplitude, which is our active light part. And we know also the offset of that signal, which is the ambient light. That's why it's very easily to extract the distance, which is the phi, and the amplitude information, which is the reflected signal amount, which is also called grayscale picture in some presentations. And of course, there's the intensity information, which is the ambient light. This is just as an overview. If someone has never seen a time-of-flight camera, we have a lens here with an Infineon chip below that, and we have a VCSEL, a laser diode to illuminate the scene at a high frequency, 80 to 100 megahertz. And then there's a USB bridge chip, so you can plug this to almost any device you can think of, except iOS devices. What you will get is the hardware, so the camera, the USB camera, with a measurement range which is according to the spec Google provided for Tango. So 10 centimeters to 4 meters at an opening angle of roughly 60 by 45. The software we give out for free. This is our SDK. So Windows, Linux, Android, Mac OS supported. You can develop on this operating system. Then we have predefined use cases to give you a good starting point for close range operation at a high frequency to at a high sampling rate for gesture, where you need a fast reaction time, or a long range operation mode for Tango-like applications. Interfaces, it's USB driver based. We have Qt for the GUI, and threading is handled internally. Okay, since this is the developer track, some words on what we provide in terms of software API. What you get out of the API is the point cloud, the XYZ information, the gray value, a noise value, and also a confidence value for each and every pixel. So it gives you the freedom to decide to use or not use the data given in the boundaries of your quality assumptions. Then also timestamping and dimensions of the frame are provided. And basically it works like there's a camera manager who is doing all the communication between the chip and the system. And then there's a camera device, a camera device, which represents the camera in the API, and then there's a listener which throws an event if a new set of data, a new depth frame is available. And of course, you get the depth data then. And depth data is the whole thing I just described with grayscale, confidence, and so on. At the same time, based on the same data stream. Well, that's the main thing. This is based on a C++ interface. We have joint teams at Infineon and pmd that work very closely together. We act as one company in terms of software development as well as a marketing business development approach. So usually I have a guy from Infineon with me, but now I'm here alone. Anyways, the guys are all in Asia. Platform independent, as said, Linux ARM is also supported. We have MATLAB interfaces for doing algorithm development. There's a C# interface, and also we have examples for OpenCV, OpenAI to dock the point cloud data to the processing libraries that are already on the market. Python support is also coming, I heard rumors. I talked about use cases. We have a laser class 1 device. That's why we have these use cases. Just to give you a rough impression, we scale the frame rate of the camera versus the exposure time to be in the same corridor of the eye safety classification. This translates also in a high working range at a long exposure time and a low frame rate, and the high frame rate for tracking at a short-range operation with a short exposure time. That is a matter of fact, you only need 1 meter, so my arm is 70 centimeters to do a hand gesture input from your own point of view. That's it. 7 seconds.